Okay, so I'm just gonna talk us through some details here. The equation we just looked at, which of course the main difference is the negative, has a graph that looks like this. Okay, let's talk about each little detail as we go along. This one has a center at 0, 0 because there's no h and k yet. Okay. There's this thing known as the transverse axis, and that's the line where the vertices, center, and foci are. So right here you can see across our hyperbola we've got the focus, a vertex, center, vertex, focus. And this time the length of the focus is longer than the length to the vertex, which was the opposite for an ellipse. In this case, for this particular type of problem, the transverse axis is the x-axis, or horizontal, like this. Okay. The vertices are going to be located at negative a0 and positive a0. You can see that I've shown that this is a distance of a, and this is a distance of a from the center. So if the center changes, that's still going to be a distance of a from the center, wherever it is. And then the focus is going to be over here at c, 0, and negative c, 0. Now notice, to make the shape of our graph, we have what's known as asymptotes, where the graph doesn't cross, but it gets closer and closer to show us where that graph is actually going. The asymptotes can be found by doing positive b over a and negative b over a. B is the distance this direction for the asymptotes, and of course a is the distance to the vertices. So to figure out where the asymptotes are, we would go up a distance of b and then over a, so rise over run, to get that asymptote. And then this one over here would be negative, a negative slope. So you could think of it as negative b over a or b over negative a. Either way, you get a negative slope going that way. So same numbers, but one of the asymptotes is positive slope and one's a negative slope, so we get those formulas or equations right there for the asymptotes. Okay, C is the longest this time, so it's just like Pythagorean theorem instead of being all mixed up like it was with the ellipses. So to find C, we just have to do a squared plus b squared and then take the square root of it. So kind of nice. Now, of course, hyperbolas can switch around so that they're going upward and downward instead of side to side. So the thing that makes that happen is changing the equation here. Notice how this equation is different from the one we were just looking at. This one has x squared minus y squared. This one has y squared minus x squared. The distance to the vertices, a, is under the x value on this problem, and the distance to the vertices, a, is under the y value on this problem. Okay, so therefore our hyperbola would go this direction, and we would have this point at 0a, this point at 0, negative a, a focus at 0c, another focus at 0, negative c, and in this case the center is still at 0, 0. Okay, now the asymptotes, remember, are still going to be rise over run, so the rise this time is a, and the run this time is the b value. So of course, to find those numbers, you would square root these numbers here. And so the asymptotes would be positive a over b and negative a over b when the hyperbola is switched to upward and downward instead of side to side. Now, of course, just like we've done with circles and ellipses, we can have the center moved at a value which we will refer to as h and k instead of 0, 0. And those equations would act just like the ones we talked about, only have this added set of parentheses and extra number to show where the center is. Otherwise, A will still be the distance from the center, C will still be the distance from the center, and B will be a distance from the center. So these types of problems make the asymptotes harder to find. You could do it, but I'm not going to make you, so that should be good.